Okay, so today's question is longest common suffix queries. So you are given two arrays of strings, words container and words query. These are the two inputs we have been given. So for each word query I, you need to find a string from word container that has the longest common suffix from word query, like CD. So this is CD, this also have the suffix CD, this also have the suffix CD, this also have the suffix CD. So if there are two or more strings in the word containers that share the longest common suffix, find the string in the smallest in length. So suppose here all have the CD, so which of the following have the smallest length? So BCD, so answer will be BCD. And find the string that is smallest in length. If there are two or more such strings that have the same smallest length, find the one that occurred earlier in the word container. That means if suppose its length was also equal to 4, then we have to find the index which is first in the list, first or the before than any other, whose index value is less than others. So we have to return an array of answer where an answer of I is the index of the string in word container that has the longest common suffix in the word query, this one. So for this we will be using try. So but in the try it is used to find the prefix, common prefix of the words, but here we have been given suffix. So what we will do, we will reverse both the word container and the words in the word queries. So after reversing we will have to find the prefix rather than the suffix. So this way we can solve this. So let's first create the try node. What will be a try node look like? So create a node. So class try node. Okay, and this try node, let's initialize the init function, sorry, method. So this node will contain the children. What are all the children of this? So self dot children, starting it will be the empty, and it will also contain the best index, best index for this particular prefix among all. So initially you can mark it as -1. So self dot best index is equal to -1. Yeah, now we have created our node. Let's try to create the try now. So create a root first. So root is nothing but the create an empty try node. So try node. Now let's create our try. So for I comma word, enumerate words container. For I comma word in enumerate words container, you can simply uh, we have to create a try. Okay, so what we will do first, we will point our node to the root. So node is equal to root, and then we have to set what is the best index. See, currently it is the empty suffix. So what is the best among these all words for the for the empty suffix, sorry. So we can set node dot best index currently better of the correct index I, and whatever is stored in this best index. So what is this beta? Beta is we have to create a function which will tell us which is the best among these. Okay, so we will just make use of sorry just make use of these conditions given here. So let's create the beta function. So define beta. It will to input I comma j. So suppose if j is equal to -1, if j is equal to -1, you can initialize it with, if j is equal to -1, suppose we have initialized it with -1, then of course I will be better, so return I. Suppose if len of words container of I is less than len of words container of j. So what we have told here, that we have to return the word with the smallest length. So smallest length is I1 here, so just return I. Similarly, just copy this. What if it's the reverse of this? Okay, suppose I is greater, so simply we have to return the j. In the last case, if both are of the same length, then we have to return whose index value is smaller. So return I if I is less than j, else return j. So this completes our beta function. Now this will tell which is the best word among this, or the best index of the word among this for that particular suffix. So currently this is a empty, so for empty all are equal. Okay, so it will give us the best among those by comparing this condition. So now simply go through each word. So for character in, and what I told that we will be finding the prefix of the reverse word, so we will reverse each word. So just reverse the word, reverse of word. Okay, for character in reverse word, what you can do, if character not in node dot children, if it's not, then we will have to create a new node. So simply create node dot children of that particular character is equal to empty try node. Okay, and next thing what you have to do, you have to mark as new node at this. So a new node will move to node is equal to, yeah, because we are tracing a word or creating a new word, so new node is equal to node dot children of that particular character. And we will also have to set this best index. So of course, so node dot best index using the same method, better among what all things, the index given and the value stored. So node dot best index. So this completes our try creation. We have inserted all the characters, all the words. Now what we will do, now we will go to the words query and find the answer. So let's create a empty list answer, go through the each word. So for word in this words, what's the name, words query. Okay, now again you have to set the node as root first. Okay, I think this is correct, node as root. Now simply go through each character. So for character in, I told that we have to reverse this also. So for character in reverse word, first character in reverse word, if character not, suppose the character is not in nodes dot children, node dot children, so we can simply break out of the loop. And if it is there, simply move the pointer. So node is equal to node dot children of current character. And finally you can, in answer you can append answer dot append the best index at the node. So node dot best index, and that's complete our code, I think. And finally we can return this answer. So let's try to run and check if this works. Okay, so we are getting some error, try has no attribute best index. Okay, where it is, node dot best index, and we have defined a self dot best index as the spelling best, self dot best index is equal to -1, and they are telling node dot best index is equal to, what's getting wrong here, attribute type over try node. Define currently try node self dot children self dot best index is equal to -1 bestindx best index, and here we are declaring node is equal to root, and node dot best best indx index is equal to better we have defined, right? Yeah, better than i comma node dot best index. This seems correct to me. What getting wrong, attribute error 2 object try node, type object try node has no attribute best index. Let me check again. So for I comma word in enumerate words container, we are doing node is equal to root, and node dot paste index is equal to better of I comma node dot paste index. This looks correct. What went wrong? So for character in reverse word, for I comma word in enumerate words container, for character in reverse word, character not in node dot children of character is equal to, oh see, mistake, we have not provided the parenthesis here. Okay, this was the mistake, and rest all things fine to me. Rest everything. Now with character not try node is equal to node character, and here again node dot best index. Then we have to find for word in words query, node is equal to root. For character in reverse word, if character not in node dot children break. Now it's look correct to me. Let's try to run and check again. Again it's pointing to the same issue. Node is equal to root. For character in reverse word, if character for character in reverse word, if character not in node dot children, uh, character not in node dot children, so node dot children of character is equal to try node is equal to node dot children of character, node dot best index is equal to better of I comma node dot best index. It's giving error here only. What's container of I, what's container of j? J is equal to minus 1. Length of words container of I is equal to length of one container of j. See, typo mistake. Words. If lane of words container of I is greater than lane of words container of j, now I think it should work. Not again. J is a lane of again. See here also. God, so many typos mistakes. So if lane of words of container of I is lane of words of container of j, if lane of words of okay, this. Now let's try to run and check. Hope this works this time. Not again. So if I better if lane of words of container I, then it's a words of container words container. Let me just copy this and paste. Typing is getting a lot of issues. Okay, just copy this and paste everywhere wherever we have used this words container. Okay, now return I if I is less than j, else j. Nothing seems wrong to me now. Lord, why it's coming so many error? Node dot best index is equal to better of I comma node dot best index. At the top, see, we have missed the parenthesis here. Oh, let's try to run and finally check. Now it should work. Yeah, so our test cases has passed, and let's try to submit and check. Yeah, so our code has passed successfully, and sorry for so many typo mistakes and this missing this parenthesis. So thank you for watching.